It looks like the direction returns. So solve the equation, give the integer or fraction answer. State if no solution or infinitely many when appropriate. So it's probably going to, on the test, it's going to say this once. But it'll mean for all the equations you're going to solve, you have to watch out for whether it's going to be no solutions or infinite. Okay, so here we have no distribution going on. So let's just do this. No parentheses to worry about. There's no combining like terms on either side of the equal sign. So now we'll start the work of getting the variables on one side and the numbers on the other. So we can do it both at the same time, but it's probably a better idea to do it one at a time. So we could subtract our choice is either to subtract 4r from both sides or subtract 2r from both sides. So if we subtract 4r, we're going to have the r's on the left. If we subtract 2r, we're going to have the r's on the right. So just for laughs, we'll subtract the 4r, or add a negative 4r. So I'm going to rewrite it 2r minus 4r minus 5 equals 2 plus 4r minus 4r. Remember, you do the same thing to both sides. If you do the same thing to both sides, you're going to be fine. And I would take the time to write each step out rather than do it in your head, unless you're really confident, because you always get them right. So 2r minus 4r is a negative 2r. Then negative 2r minus 5 equals 2 now, or I could say plus 0. 2 plus 0, which is just 2. Alright, so now we want to get our constants, our just plain numbers, on the right side. And that doesn't include this number. That number's we're not going to worry about yet. Okay, so well, to do that we have to add 5 to both sides. Negative 2r minus 5 plus 5 equals 2 plus 5. Now here our negative 5's cancel out on the left side, so we have a negative 2r equals 7. Alright, so now to get the r alone, and we want it to be a positive r, so we have to divide here. It's our multiplicative property. So you notice we used the additive property first. We start with the additive property. Well, we start with eliminating parentheses and taking care of distributions and combining any like terms we can. Then we go to the additive, and then we go to the multiplicative. So now we're at the multiplicative, which includes division. If we divide by a negative 2, that will be just 1r. We have to divide this side by negative 2. So those two cancel out. We get r equals 7 over a negative 2, or a negative 7/2. Number 16. 3/10 x plus 2/5 equals 1/5 x. Alright, now here we want to clear fractions. We could add these together. You know, we could work it as fractions, but it's always easier to clear the fractions, and that's actually what we want you to get experience doing. So that even though this is a relatively simple problem, it'll be a lot easier for us to deal with if we don't have fractions. So you have to look at it and say, well, what's the least common multiple, or least common denominator between 10 and 5? And that would be 10. The least common denominator always has to be at least as big as the largest denominator. It can't be smaller. Okay, because then you're going to end up with complex fractions, fractions of fractions in fractions. So you don't want that. So the least common denominator in this case is 10. So we're going to have 10 times 3/10 x plus, and then it's going to be 10 times everything on the side. Well, I'm going to do it a different way. Okay, we will multiply 10 times both sides, right? You do the same thing to both sides, everything's going to be fine. And we had to use the least common denominator, which is 10. Now, again, this is a distribution now. We've got to multiply the 10 times the 3/10 x, and we've got to multiply the 10 times 2/5. So we can do that over on the side. you separate out things if you want. 10 times 3/10, which is the same as 10 over 1 times 3/10. And you can say, all right, we've got 30/10, which equals 3. Or you could do it cross-canceling. 10 into 10 goes one time, 10 into 10 goes one time. 1 times 3 is 3. 3 over 1 equals 3. Okay, so we've got 3, but we've got the x. Don't forget about your x. I just multiplied the numbers times the numbers, but we've got to keep the x too. Alright, so now we've got our 2/5. We've got to multiply 10 times 2/5. We'll put the 10 over 1. We'll do the cross-canceling. 2. 2 times 2 is 4. 4 over 1, which equals 4. So this is plus 4. And that equals 10 times 1/5, which I think I'll do down here. 10 times 1/5, 10 over 1, equals 2 over 1, or 2. Okay, so we have 2. So now it's an easy problem to do, right? That's much easier than what we had up here. So now we'll say, all right, well, we want to get the x alone, x term alone, so we're going to subtract 4 from both sides. Try to keep your equal signs right underneath each other. So we'll go 3x plus 4 minus 4 equals 2 minus 4. So then we end up with 3x on this side equals a negative 2. Okay, so now to get it x alone, we've got to divide by 3. Divide by 3. Let's cancel out. And let me get this out of the way. Then we end up with x equaling a negative 2/3. Okay, here we are with decimals. Decimals and fractions are really all just fractions. They're all parts, right? So we're going to have to deal with the decimals. And decimals are actually easier to deal with than fractions. For instance, up here, we've got 5 and 2/10 m. And all we have to do is multiply that by 10. If you multiply, if you multiply 10 times 5.2, for example, you just have to move the decimal point one place, and you would get 52. This is how it works with powers of 10. So it's easier. If we had 1/10, and we were going to multiply 10 times 1/10, 10 over 1, we get 1, right? 1/10. 10 times 1/10, we move the decimal point one place, we get 1. If we have 100 times 1/10, well, we move the decimal place two places, go 1, 2, put a 0 in there, and we get 10. So it's actually easy to multiply tens times decimals. You're not going to have to multiply other things times decimal. And it's easier to do that. It's easier to clear all the decimals up there than it is to add all and subtract and divide by decimals, because it's easier to make a mistake. There's just more to do. Okay, so we're going to multiply both sides. We'll look and see how many decimal points are there in there. No number has more than one decimal place. All of them have just one decimal place. So one decimal place means you multiply with a number with 1 0, a 10. If there was something with 2 decimal places, you'd multiply by 100. 3 decimal places, you'd multiply by 1,000. So here, we'll multiply by 10. 10 times negative 5.2 m minus 7.7 minus 1 m equals 10 times a negative 7.9 minus 6.2 m minus 0.2. Okay, so again, this becomes a distribution problem. We're going to multiply the 10 times this one, and then this one, and this one. And then this one, we're going to multiply it times that one, that one, and that one. Any number that's inside of parentheses with another number outside that's multiplying, you multiply it by each term. Even if there's 100 terms in there, you multiply each one. So we don't have 100 terms. So 10 times the negative 5.2, move the decimal place once. We get a negative 52m. And then 10 times the negative 7.7, move the decimal point once. We get a negative 77. 10 times 1, the decimal point for 1 is right there, so we actually move, whoops, no, we just have to move it one place, excuse me. So it would be 1 minus 10m. Okay, on this side, 10 times the negative 7.9 would be a negative 79. 10 times the negative 6.2, move it one place, we get a negative 62m. 10 times 0.2, we'll just move the decimal point one place, so we get a negative 2. Alright, now we have integers, so we can deal with that. As a matter of fact, if you notice that all the numbers are negative, if we wanted to, we could multiply both sides by a negative 1, or I could have used a negative 10, right? Which means we would eliminate all the negative numbers, but we don't have to do that. So we could combine like terms, and if you can, you could just do it, you know, without moving things around. Negative 52m plus a negative 10m gives us a negative 62m. Okay, and then that's minus 77. We're combining like terms on both sides. And here we have a negative 79 and a negative 2, which gives us a negative 81. And then that's minus 62m. Now, I don't know if you're seeing this like I'm seeing, but I can see that negative 62m. I could subtract that, or I could add a 62m on both sides, and all I would have would be a negative 77 equals a negative 81. And what does that tell you? Right? What kind of solution is there for this? Let's do it. We're going to add 62. I'm just going to do it over here to save trouble. 62m. Whoops, there's an m. That's supposed to be an m. Okay, so I'm adding 62m to both sides. So that gets rid of these. Gets rid of the negative 62m. That becomes 0. So now we have a negative 77 equals a negative 81. Well, it doesn't equal a negative 81. So this problem, so you need to indicate that. Okay, another equation. They just keep coming. All right, remember we're watching for no solutions or infinite solutions, right? And of course, what we're usually going to get from these is one solution. It's only one term, so it's going to be one solution. All right, now when you look at that, we've got 9x minus, and then in parentheses 2x minus 1, and that equals 2. There's a distribution problem here. This negative has to be times both of those. And you can think of this as either negating everything inside there, so it becomes a negative 2x and a positive 1, or you can think of it as this. Negative 1 times 2x minus 1. And that equals 2. Whichever way works best for you. Okay, so remember, like if we just have x, for instance, if we just have x, we assume that the 1 is there. Also, you may not know this, but we're assuming that there's a power of 1, which makes the x stay the same too. See, but we don't write those in because we don't need to. Alright, so let's do this distribution first. We'll keep the 9x, and then minus 1 times the positive 2x is a negative 2x. Negative 1 times the negative 1 is a positive 1. And that equals 2. Okay, so now we're going to combine like terms. We have a 9x minus 2x gives us 7x plus 1 equals 2. Alright, so now we want to keep our x terms on one side and our numbers on the other. So we'll subtract 1. And we have 7x plus 1 minus 1 equals 2 minus 1. So that gives us 7x equals 1. And then we've got to use the multiplicative property of equality by dividing both sides by 7. Cancels, we get x equals 1/7. Notice there's just one solution here. Number 19, 1/3 y equals 4/5. Okay, again, we want to clear the fractions. We don't want to have to be adding, subtracting, multiplying, dividing fractions. So let's do that here. We can multiply both sides by the least common denominator, turn it off and see if you can figure it out on your own, then come back. Okay, the least common denominator is 15. 15 times 1/3 y equals 15 times 4/5. Okay, 15 times 15 times 1/3, 15 over 1, cross cancel, and we get 5. 5 over 1, or 5. Alright, so here we have 5y, and that equals 15 times 4/5. 15 over 1. Let's say I don't cross cancel this time. 4 times 15 is 60 over 5. And 5 into 60 is 12. If we cross cancel that, it's easier, you see. Divide 5 into this gets 1. That's 3. 3 times 4 is 12. Okay, so now we have 5y equals 12. Using our multiplicative property, divide by 5, divide by 5, get y equals 12/5. One solution too, by the way. Okay, now somebody watching this has got to say, wait a minute. There's got to be an easier way of doing that than finding the least common denominator and multiplying both sides with it. And in this situation, yes, there is. You see, you would definitely want to find the least common denominator if, for instance, there was, this was plus 2/5 y on the other side. You know, if you would definitely want to multiply both sides by 15 because you couldn't. Because in the problem we have, we could just multiply both sides by 3, and that would eliminate the constant here, and then we'd have y equals 12/5 also, and which I'm going to do for you. So a lot of cases you can't do that, but in this case you can multiply, since we only have this one constant times the y. We can multiply by its reciprocal, and its reciprocal is 3, or 3 over 1. So if we multiply this by 3 over 1 times 1/3 y, and this would be 3 over, well, we don't, yeah, put it over 3 over 1 times 4/5. These two cancel out, and we get y equals 12/5. So math is about finding the easiest way to get the right answer, right? Number 20, negative 4x plus 3 times, parentheses, negative 3x minus 7, close paren, equals negative 25 minus 9x. Okay, I don't have a heck of a lot of room here. Now, if you're working on a test or something and you don't have enough room, get another sheet of paper out. In this case, I think I can make this fit, but you don't want to take a chance of getting the problem wrong just because you didn't have enough room to work. Okay, so we're going to take care of our distribution first. We're going to multiply the 3 times the negative 3x and times the negative 7. Copy everything else down. Negative 4x plus 3 times the negative 3x is a negative, I guess I'll put it in parentheses then, negative 9x. 3 times the negative 7 is negative 21. You have to, with these distributions, you've got to watch the signs, make sure you're, yipes, there we go. Okay, so on the left we're going to combine like terms. I can eliminate those parentheses. Okay, and combine the negative 4x with the negative 9. Gives me negative 13x minus 21, and that equals a negative 25 minus 9x. Okay, so put the get the variables on the left and the constants on the right. I will add 9x. I barely have the room here. Add 9x. So I get negative 4x minus 21 equals negative 25. Alright, now I'm going to add 21 to both sides. So plus 21, because I'm running out of room, I'm not going to get fancy here. So we have a negative 4x equals a negative 4. And then we can divide by negative 4. Divide by negative 4. And that gives me x equals 1. Right over here, x equals 1. Don't do this. This is you could take it. I can't take an extra piece of paper because I can't shove that into this computer. Anyhow, x equals 1. Of course, we have one answer. So now let's test this. It's x equals 1 is our answer. X equals 1. But let's test it in the equation, make sure we're right. You can always do this. Negative 4 times 1 plus 3 times a negative 3 times 1 minus 7. And that equals a negative 25 minus 9 times 1. And that gives us a negative 4 plus 3 times a negative 3 minus 7 equals negative 25 minus 9. So we have a negative 4 plus, this is 3 plus 3 times a negative 10 equals negative 25 plus a negative 9 would be a negative 34. Okay, let me break it down here. We have a negative 4 plus 3 times a negative 10 equals a negative 34. Okay, 3 times a negative 10 is a negative 30. That's plus a negative 4 equals negative 34. So negative 34 equals a negative 34. Now notice, we got negative 34 equals negative 34. Now that doesn't mean there's infinite solutions. That's just from when we stick the solution back in and test it, we want to end up with the same thing equaling the same thing. Okay, so that's different than ending up solving a problem and finding out that 34 equals 34 or x equals x. Okay, so anyway, we got that one right. Number 21. An equation which can be written in the form ax plus b equals 0 is called a what kind of equation? It's called a linear equation. Because if we graphed it, we would find it, we would have a line. And that's the form it would take. So, for instance, if we had 2x plus 3 equals 7, we can say, well, that doesn't look the same. How can we tell if that's a linear? Well, we can move things around. We have to have it equaling 0. So to do that, we would subtract 7 from both sides. Okay, I'll just add a negative 7 to there. Okay, and then we'll add the negative 7 from positive 7 is 0. So we have our 0. And then the negative 7, we'll combine that with our positive 3, and we'll get a negative 4. So then we have 2x minus 4 equals 0. And we say, well, wait a minute. How can we say that? Because the b is positive. Well, the b can be positive or negative. So in this case, our a is 2, and the b is a negative 4. And that is in the linear, the standard form for a linear equation in one variable. So if we can change an equation around so it takes this form, then it's linear. Number 22. The equation of x plus 7 equals x plus 7 is an example of an equation with infinite solutions. Because you can stick any number in for x, any number, so that's infinite solutions. Okay, now determine whether the equation, here we go, giving us the directions again. Determine whether the equation has no solution, one solution, or infinitely many solutions. Alright, so we have to solve it first. But can you tell just from looking at it? Actually, we don't have to solve it. We can just look at it. You can see you got 7x equals 7x, and then minus 28. Try to stick a number in there. Don't just look at it and say, oh, I can't remember. You know, just stick a number in there and see. Okay, if we stick 1 in there, we get 7 equals 7 minus 28. Well, that isn't true. If we stuck in 100 in there, we get 700 equals 700 minus 28. Still not true. We stuck 0 in there, we get 0 equals a negative 28. That's not true. So this is a situation where there are no solutions. Of course, we could take it and go 7x, whoops, 7x equals 7x minus 28, and we can subtract 7x from both sides, or add a negative 7x to both sides. Okay, these turn to 0. These turn to 0, so then we have 0 equals a negative 28, which can't be true, so it's a no solution situation. Uh-oh, a word problem. Well, I can't do word problems, right? Well, let's try anyway. Okay, so brandy soup contains 955 milligrams of sodium. Write a formula that computes the number of milligrams of sodium S in X cans of brandy soup. All right, so why don't we just pretend at first that it's not 955 milligrams of sodium. Let's pretend that it's 9 grams. That's an awful lot of sodium. Well, let's say that's a lot of sodium too. Okay, 9,000 milligrams. Anyway, okay, let's say that it had 9 grams of sodium, and we write a formula that computes the number of sodium S in X number of cans. So more than, say, so this is going to be the amount of sodium, and we're going to have a certain number of cans, X cans, and 9 grams. So if we had 1 can of sodium, we'd have 9 grams, right? 2 cans, we'd have 18. 3 cans, we'd have 27. 4 cans, we'd have 36 grams, right? So basically, the number of grams we have is the number of cans multiplied by the number of grams. So in this case, it would be 9 times X, right? But we don't have 9 grams. We have 955 milligrams. So we're just going to change it. It's easier to understand it from using smaller numbers. Okay, so our soup equals 955x. And no matter how many cans we put on there, we'll just multiply the number of cans times the 955 because that's how much is in each can. Okay, and that will be the formula.